Well, hello there, guys. This is Mr. Roden, and welcome to your asynchronous lesson brought to you by me, Mr. Roden. Now, obviously, I'm your math teacher for some of you, and I'm not your math teacher for others. So, just wanted to introduce myself if you haven't met me yet. So, I'm going to be doing your asynchronous Monday math lesson. Um, and so here we go. Let's give it a try. Now, before we get started today, I will tell you this. Some of you have seen this already, and maybe you've had notes on this. Some of you have not seen this already. Some of you have maybe seen this in another class, like in seventh grade, or so this could be a review or this could be new. So we're all at different places in our learning, but hopefully this will catch everyone up, and we'll all be ready to move on to the next unit after the next section after this. Okay, so let's take a look at the learning target for today in green here. So the learning target today is I can simplify and solve problems that involve exponents. Okay, so what is an exponent? We're going to talk about that today, and we're going to solve problems with exponents. And again, some of you have seen this already, so this is going to be a little bit of a review. Nothing wrong with reviewing stuff, guys. Okay, it's always good to be strong on this stuff because you keep seeing it in math. All right, so let's look at our agenda. I say good thing because I'll be giving the good thing because I don't have you guys live today. We'll do a warm-up, and then I'll introduce 9.1 Introduction to Exponents. So you may have seen this already, and you may have already gotten a lesson on this, but you're going to get a lesson from Mr. Roden also. Okay, so let's go ahead and do a warm-up really quick. So I'm going to kind of scroll down here. I have 5 problems here, and it's kind of, these are 5s up here. I can't see my whole screen. So 5 plus 5 plus 5 plus 5. I just want you to tell me what the answer to that is. 3, -3 plus -3 plus -3. Tell me the answer to that. 4 times 4 times 4. -6 times -6. And -2 times -2 times -2. Could you please go ahead and pause the video right now and just give me the answer to those? That's all I need you to do. Okay, so go ahead and pause. Hey, welcome back. So let's go ahead and take a look at the answers here. Well, you're probably asking yourself, Mr. Roden, this is the easiest thing I've ever done in my life. Why are you having an 8th grader add 5 4 times? Because I know that 5 plus 5 is 10, 15, 20. So this is 5, 10, 15, 20. Mr. Roden, that is so easy. Okay, why are you having me do this? Now, number 2, it's a little more challenging, but not much. -3 plus -3. Well, that's -6. And -6 plus -3 is -9. So your answer there should have been -9. Now we're going to talk multiplication. 4 times 4 is 16. And 16 times 4, I believe, is 64. Now we need to remember our rules when we multiply negative numbers. A negative times a negative is a positive. So this is going to be a positive answer. And 6 times 6 is 36. So the answer here is positive 36. Let me scroll down a little bit so we can see this last one right here. All right, so the last one is -2 times -2. Well, I'm only going to multiply it in pairs each time. So -2 times -2 is positive 4. But then I need to multiply it times this -2 right here. And what is positive 4 times -2? A positive times a negative is a negative. So this is going to be -8. And that's your answer there. Now, I'm hoping that you did well on this. If you made a mistake, that's okay. But let's go back and let me show you why I gave you all these 5 warm-ups. I was very strategic in when I did this. What do you notice about each one of these warm-ups? They all have something in common. Well, yes, they all have something in common. Number 1 and 2 are repeated addition problems. Number 4 and 5 are repeated multiplication problems. So they're similar in that they're all repeating an operation, either addition or multiplication. They're different in that the first 2 are repeating addition and the last 3 are repeating multiplication. Now, when you were a little teeny kid and you learned how to add, and after I'd say about the 3rd grade, your teacher taught you that there's a shortcut besides just counting by 5s or adding 5s. there was a shortcut to repeated addition. And what was that shortcut? You would copy down the number that's being repeatedly added, and then you probably had a x for a times, and you'd multiply. How many times were you repeating the addition? You were repeating it 1, 2, 3, 4. So another way to say 5 plus 5 plus 5 plus 5 is 5 times 4. This was a multiplication, is kind of a shortcut. Okay? Likewise, if you're looking at number 2, you probably didn't have negative numbers in the 3rd grade, but the same kind of system applies. What's the number that's being repeatedly added? Well, it's -3. Okay, and how many times did you repeat the addition? 3 times. So this is -3 times 3. Okay, later on, we stop using x's. So nowadays, we probably say 5.4 for multiplication. And now we'd say -3.3 for multiplication, because we use x for variables now. Normally, we don't use x for multiplication. But when you first learned it, my guess is you use an x for multiplication. All right, so our lesson today is going to involve how do we do a shortcut for these type of problems, repeated multiplication. And that's what we're going to be doing today. So this warm-up was to get you thinking about the past and what repeated addition was. Repeated addition is multiplication. So now let's talk about what is repeated multiplication, because that's a little different. So let's go ahead and take a look at that. Scroll down here a little bit. Okay, so what is an exponent? An exponent is and I want you to write this down. An exponent is a shortcut way. I like to call it a shortcut way, or a shortcut method, because we're all about the shortcut in math. We're always trying to shorten the process. We want to simplify it. We want to make it less writing. We want to use symbols instead of that can show lots of different things. So it's a shortcut or simplified way. A simplified method. We'll make it sound smart. We'll use the word method of writing repeated multiplication. And hopefully you're writing this down. And hopefully you can read my handwriting, because my handwriting can be a little messy sometimes, but that's multiplication. Okay? So that's what exponents are. They're repeated multiplication. So let's take a look at what we have when we have an exponent. Okay? So let's say that I have, and before we do this, I'm going to kind of come down right here. Let's say I have, kind of ignore this little colorful thing. And let's say I have 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. So I have 3 being multiplied 5 times. 5 times. That's 5 right there. I got to find my camera. 5 times. Okay. So what does it mean to multiply 3 5 times? Well, you can write this. Here's the shortcut method. So first of all, the number that's being multiplied is called the base. Okay, that's the number that's being, it's the number that, notice it's 3, 3, 3, 3, 3. The base has to always be the same. The number of times it's being multiplied. In this case, the multiplication is being repeated 1, 2, 3, 4, 5 times. So the number of times it's being multiplied is 5. And that number of the repeated multiplication number is the exponent. And if we wanted to give this whole big package here, a base and connected to an exponent, if we wanted to give that a name for the entire thing, we call that a power. Okay? So a power is the whole package. It's the base with the exponent included. The exponent is the number of times the multiplication is being repeated. And we notice we write it as a small uppercase to the right. Small, it's not uppercase, but superscript, usually we call this, right? And it's up in kind of the right-hand corner. We try to make it small. And then the base is big, like a regular number, okay? So that's what kind of an exponent is. And the whole thing is a power. Okay, so hopefully that makes sense for you. All right, so let's do an example. So example number 1, and I'll do this one. So I'm sorry, my picture is in the way of the problems. Let me kind of come up here a little bit. Let me do this. Let me move this down a little bit. Sorry. All right, cool. So now, there we go. So, all right, cool. So we want to write this as an expression with an exponent. So remember, when there's no symbol in between, there's no operation in between, we assume multiplication, okay? So this is assumed multiplication. And the reason they're in parentheses is not because there's work to do. The parentheses is showing that this negative and 7 is grouped together. It's one whole package. These ones is package. Okay, so what are we going to do? Well, the first thing we need to do is decide what the base is. Well, what's the number that's being repeatedly multiplied? Well, that is -7. And I'm going to put it in parentheses because remember, parentheses tells me it's one whole thing. It's not just the negative. It's not just the 7. It's both. It's a package deal here, the -7. Now, how many times is this going to be multiplied together? Well, 1, 2, 3, 4. So I'm going to write that as an exponent. I'm just going to put a little 4 right here. Easy. A lot of you already know this. I know. So this is a review. But if you didn't know it, it's kind of cool, right? This is a way we can simplify. It's a shortcut. Isn't it easier to write this than that? That could make your hand tired writing all those -7s. This, you only have to write -7 once with a little baby 4 right there in the upper right, and you're good. Okay? All right. So you go ahead and pause the video now, and I want you to write, this is pi, the number pi times r times r times r as an exponent, as an expression with exponents. So pause the video now and go ahead and do it. I'm watching you, so pause. Okay, welcome back. Hopefully you did a good job. Now, in this one, you got to be a little careful. Because I knew that you guys were just like saying this is too easy, so I threw a little twist at you here. So the twist is there's actually 2 bases. Ooh, well, let's highlight those bases. Well, the first base is pi. Remember, pi is an irrational number. That's just a little review. It doesn't really have anything to do with what we're doing, but it's irrational because we learned that last week. Okay, so now we have repeated multiplication of pi. And how many times is pi being repeatedly multiplied? Well, 2 times. So it's going to have an exponent of 2. Now we have, let me change my color here. How about to blue? That's a nice aqua blue color. And now we have a r. Okay, so how many times is r being multiplied? Well, r is being multiplied 3 times. So the base is, should I get my black pen here? The base is r, and the multiplication that's being repeated is 3 times. And you're done. You cannot do any more work with this. Pi and r are different bases. You cannot do anything with these numbers because this 2 is connected to the base of pi, and this 3 is connected to this exponent of 3 is connected to the base of r. There's nothing more you can do. You can't like try to put these together or anything like that. You're done. Nothing you can do there. Okay, awesome. Let's look at the next example. Now we want to do evaluate. Evaluate is and I want you to write this down because a lot of kids don't understand what the word evaluate means. So evaluate in math means do all the math. Do every single thing you can mathematically to simplify this out. Simplify means maybe put things together and make it look like a nice package, with not a bunch of stuff. But when you evaluate, you need to do all the math you possibly can. So let's take a look. Well, we have -2 to the 4th. Well, the first thing if we're going to do math is we probably need to expand this out. So this is an exponent form. Now I'm going to write it in expanded form. And here's what expanded form does. Well, the base is -2 and the repeated multiplication is 4 times. So before I do any math, I'm going to write it out in expanded form. So -2 times -2 times -2 times -2. Notice this problem is not going to be down -2 to the 4th power. That's not what this is. Okay, this is this is not -2 times 4. It is -2 to the 4th power, but this is not -2 times 4. This is -2 repeatedly multiplied by itself 4 times. 4 times. Okay, all right, so let's do this. So -2 times -2 is +4. These, I like to multiply in little pairs. -2 times -2, that's also +4. And +4 times +4 is 16. And remember, guys, a negative times a negative is a positive. A negative times a negative is a positive. So 2 positives equal a positive. So we get 4 times 4, which is positive 16. And that's our answer. We evaluated it. We did all the math. That's what evaluate means, do all the math. Okay, so let's do the next problem. All right, so your job is to evaluate this one. Go ahead and do evaluate negative 2 to the 4th power. Now, right now, you're probably saying, Mr. Roden, you just gave me the same answer. You gave me the same problem. I have a negative 2 to the 4th here, and I have a negative 2 to the 4th here. But I was being tricky. So give it a try. See if you get the right answer, but be careful. This could be a little tricky. Hey, welcome back after pausing the video. Let's take a look at this, all right? So we got negative. Now, notice the negative is not in the parentheses. So how does that affect the problem? It means that this negative is not being raised to the 4th power. It's just kind of hanging out by itself, and it's just going to tack on to the final answer. So if this is my answer right here, let's say this is my answer box right here. I'm going to put my final answer in that box. I know that my final answer is going to have a negative tacked onto it because this negative was it's not part of the exponent, so it just comes along for the ride and gets to tack on to the very end, okay? So the only thing that's actually being repeatedly multiplied, because there's no parentheses around it, is the 2. So this is really just 2 times 2 times 2 times 2. Notice the negative is not being repeatedly multiplied because it's not in parentheses. If this was in parentheses, then yes, we would do negative 2 times negative, but it's not. So let me get rid of that because those parentheses don't exist in this problem. The negative is just along for the ride and gets to tack on to the final answer. Well, again, we know this. 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16. So that 16 is going to go inside the box with that negative that was just along for the ride. And we are done. Okay, order of operations. And we've been doing a little of this like in our fair game review and things like that. So this should not be a big deal. So let's just kind of go through our Gemdas rules. So grouping, anything grouping is parentheses and brackets and square roots, things like that. And then we got exponents. That's what we're doing today. Like 3 to the 4th is an exponent. So I'll just kind of put that in there as an example. And then we have our multiplication and division. And then we have our addition and subtraction. So this is our Gemdas rules. Okay, multiplication and division. And then we have our addition and subtraction from left to right. So we're going to go through this rule. Okay, so let's look at example 5 here. Now, do we have any grouping? Do we have any square roots? Do we have any brackets? Do we have any parentheses? No way, we don't have any of that. So we're going to move on. Check. Do we have any exponents? Well, yes, we have 3 to the 4th, right? Well, what is 3 to the 4th? Let's do a little side problem. 3 to the 4th is equal to 3 times 3 times 3 times 3. Now, I'm going to multiply in pairs here. 3 times 3 is 9. These two 3's are 9. 9 times 9 is 81. So this is going to be 3 plus 2 times 81, because 3 to the 4th is 81. Notice 3 to the 4th is not equal to 12. We're not taking 3 and multiplying by 4. Okay, that's a really common mistake kids make. All right, so what's the next thing? Well, we need to do multiplication and division from left to right. So let's do that. So multiplication and division from left to right. So, 2 times 81. We'll do that off to the side over here. 81 times 2. So 2 times 1 is 2. 2 times 8 is 16. So that's 162. So I have 3 plus 162. And then I add those together. 3 plus 162 is 165. And that's my final answer. All right. I want you to go ahead and try example number 6. Let me give you a little more room here. I'm going to give myself a little more room here. So do this. Get out of here, guy. Okay, awesome. So your job right now is to do number 6. And so number 6 is right here, example 6. I'll separate it from that. Okay, go ahead and pause the video. I want you to pause. I'm watching you. Go ahead and pause the video, and we'll see you after you're done. Hey, welcome back. Hope that problem went okay with you. All right, so let's go ahead and do our Gemdas, and let's see if you got it right. Okay, do we have any grouping? Nah, we don't have any grouping, no exponents, no square roots, anything like that. No parentheses. We do have exponents, but that's not part of grouping. We don't have any parentheses. We don't have any brackets. We don't have any square roots. So we do not have any grouping. So move on to the next one. Do we have some exponents? Well, yes, we do. We have 8 to the second power. All right, so what is 8 to the second power? 8 to the second power is 8 times 8. And what is 8 times 8? That's 64, right? So hopefully I don't need to write that out for you. So we have, oh, and we also have 3 to the third. I saw that. So we also have 3 to the third as an exponent. So we want to do that also. Well, what's 3 to the third? 3 times 3 is 9, and 9 times 3 is 27. So what do we have here? We have 27 minus 64 divided by 2. So now we're done with our exponents. Now we want to do multiplication and division from left to right. So multiplication and division from left to right. Okay, do we have any multiplication and division? Well, yes, we do. We have this problem right here. Let me highlight it. This is our multiplication and division problem. We have 64 divided by 2. And what is 64 divided by 2? 64 divided by 2, if you're not sure, you can always go off to the side and do a pen here. You could always take 64 on the inside and put a 2 here. 2 goes into 6 3 times. 2 times 3 is 6. Subtract, bring down your 4. How many times does 2 go into 4? Well, 2 times. Remainder is 0, so your answer is 32. Now, some of you could have done that in your head, but hey, who knows? Some of us are good at division in our head. Some of us are not. Doesn't matter. We can do it both ways. So now we have 27 minus 32. And so now what is 27 minus 32? Now, the first thing we have to notice is we're going to get a negative number here, right? Because you have $27 and you're taking away $32, you're losing money. If you're a football player and you gained 27 yards and then you lost and you took away 32 yards because you had a lot of penalties or something, or you lost it, so you fumbled the ball and had to run backwards or something like that, you're losing, right? If you're at 27 feet above the water and then you go down, you're going to go down into the water. So whatever it is, this thing is going to be negative because it's a bigger number being subtracted from a positive number. And what's 27 minus 32? Well, 32 minus 27, I believe, is 5. So our answer is going to be negative 5. Is that what you got? Hopefully. All right, let's go. Let's do the next one. All right, number 7. I want you to find the error in the work. Error. I just say error. I like to say it funny. Okay, so what is the error in this work? Okay, so scan it, pause it. Why don't you pause the video really quick and see if you can't figure out what the error that I made here. Ooh, I made an error and I just realized it. What is that error? Okay, welcome back. Well, if you didn't notice, the error is that this is a base and an exponent. Remember, we never multiply the base times the exponent. This is wrong, okay? This is not 5 to the third equals 5 times 3. It's not 15. This is 5 times 5 times 5. Well, 5 times 5 is 25. 25 times 5 is 125. It's actually the correct answer is much larger than the mistake answer. Notice, exponents get big fast. They get big. They grow very, very fast. And so now you could see that 5 to the third power is 125. Okay, 5 times 5 times 5. Okay, I have a last problem here for you. And I want to kind of talk about this last problem a little bit. So there's this rule in math. Let me give myself some more room here. Awesome. So there's this rule in math that says every number can be written as a product of primes, a multiplication of prime numbers. Well, what's a prime number? Well, a prime number is a number that can only be, it only has a factor, or it can only be divided by 1 and itself. And the one rule that doesn't really kind of make sense, but we have to always remember that 1 is not prime. 1 is not prime. And I'm not going to go into why, because it kind of seems like it could be prime. But in this class, in most math classes, we always say 1 is not prime. Okay, so if 1 is not prime, what's the first prime number? Well, it's 2, because 2 can only be divided by 1 in itself. Okay, what's the next prime number? Well, 3, because 3 can only be divided by 1 in itself. What about 4? Is 4 a prime number? No, 4 is divisible by 2 and 1 in itself. So 4 is not. What about 5? Yes, 5 is prime. Okay. What about 6? No, 3 and 2 go into 6, not just 6 and 1. What about 7? Yes, 7 is prime. What about 8? No way. 8 has factors of 2 and 4 also. What about 9? A lot of people think 9 is prime, but it's actually not. 9 is not prime because 3 times 3 is 9. So 9 is not prime. Is 10 prime? No. 2 and 5. What about 11? Yeah, 11 is prime. So hopefully you can start to see that what the prime numbers are. So 13 would be the next prime number, not 14, not 15, not 16. 17 would be the next prime number, not 18. 19 would be a prime number. So hopefully you're starting to see these prime numbers. So every number can actually just be written as a multiplication of these prime numbers. But what we're going to do is we're going to write it as a power, or we're going to use an exponent in our final answer. So let's say we came up with the number 124, okay? And we want to write the number 124 as a prime number, a product of primes, basically an exponent, a multiplication problem that has exponents in it. Well, you're probably like, what's that all about, Mr. Roden? Well, let's take a look. Well, first of all, I'm going to ask myself, what goes into 124 besides 1 and 124? Is there a number? Well, it's even, right? Even numbers are always divisible by 2. So I think I can break this down in my head. So let me just do this off to the side. If I take 124 and I divide it by 2, well, 2 won't go into 1, but it goes into 12 6 times. 6 times 2 is 12. 0, bring down a 4, and then 2 goes into 4 2 times. So this is 4, remainder of 0, right? So we know that 2 times 62 is equal to 124, right? Okay, so that's good. So now, do we have any prime numbers here? Well, yes, we do. We have the number 2. And I'm just going to circle these prime numbers so I remember what they are. Okay, now, is 62 prime? No way. Guys, even numbers are never prime unless it's a 2. 2 is the only even prime number. So here's the deal. 62. Well, if let's see here. Well, if it's even, then 2 can go into that. Okay. So let's go 62. 2 goes into 6. Let's see here. I bet you know it in your head. Some of you can do this in your head. I think I can do it in my head, but I want to show you the division. So 2 goes into 6 3 times. 2 times 3 is 6. And then bring down the 2. 2 goes into 2 1 time. And then 2 times 1 is 2, remainder of 0. So 31. So this is going to be 2 times 30. I'll make my 2's look the same here. This is going to be 2 times 31. All right, is 2 prime? Yeah, 2 is the only prime number. What about 31? Is 31 prime? It actually is. There's no number besides 31 and 1 that divides 31. So 31 only has factors of 1 and itself. Therefore, it's prime. So I'm going to circle it. So now we're not done because this is an exponent lesson, right? So let me erase this stuff because this is just a little side work here. Find my eraser here. Erase all this stuff. And what we want to do is we want to write this as an exponent. Well, first thing we do is we find some bases. So remember, this is all being multiplied together. 2 times 31 equals 124. Remember, any number can be written as just a bunch of prime numbers multiplied together. That's why prime numbers are so important. They're like the building block or the fingerprint of all other numbers. Okay? So how many times is 2 being multiplied? Same base. Well, that's going to be 2 to the second. And then times, how many times is 31 being multiplied? Well, just once. Now, you could do this. I'm fine with this, and I might even just leave a little 1 here. This 1 is not necessary, but sometimes it's good to see it. So this problem as a product of primes is, a product means a multiplication problem, is 2 to the second times 31. And we're done. Now, I have just realized that I did not give you my good thing. I went through the list. If you go back way up here, I didn't give you my good thing. And I thought about that when I was doing, I got so excited about doing exponents that I forgot to give you my good thing. I went straight to the warm-up. So let me give you my good thing now. So if you're like really worried about my good thing, I'm going to give it to you now. My good thing is that when I'm taping this, you're going to see it on Monday, but I'm doing it on a Friday. And what's great about Fridays? What's great about Fridays is it's the weekend, and weekends are fun, right? And so I'm just looking forward to just having a relaxing, nice weekend, getting outside, hanging out with my family. So I'm really, really looking forward to the weekend. But I'm going to be very excited to go back to school because I like teaching math also. All right, so here's the deal, guys. When you have, you're going to do the 9.1 homework, okay? You have it done before your teacher's deadline. Now, Mr. Sansoni might have a different deadline than Ms. Horner or than Mr. Roden, but find that 9.1 wherever your teacher puts it into their Schoology site and start working on that and make sure it's done before the deadline, guys, okay? All right. Hope you're having a great Monday. I know why I'm having a great Friday, but when you see this on Monday, I hope you're doing well, and I hope this lesson helped you understand exponents better. See you later. Bye.